I wanted to ask you, see if we can kind of address the skeptics head on, because I know that you're a famous skeptic, Dr. Krauss. I wanted to read a quote here. According to NASA, there are multiple studies published in peer-reviewed scientific journals that show that 97% or more of actively publishing climate scientists agree climate warming trends over the past century are extremely likely due to human activities. Some 3%, however, are not of this opinion. So I wanted to ask you, have you ever encountered any argument from these dissenters, those scientists that are breaking with consensus that is worth steel manning? Is there any interesting arguments coming from that side of the
Well,
faction at
let's
all?
let's first say I hate that statistic. Okay, I
Mm,
hate the use of that statistic. Science is not done by democracy. We don't
mm.
all vote say, okay, we all think gravity makes you fall. Oh, you don't think gravity makes you fall? Okay. Oh, maybe 40% of you don't think? Well, then gravity doesn't make you fall. Okay. I mean, it's not done that way. Okay.
Mm,
And you make predictions, you test them, and the theories that work, and the ones that
mm.
don't get thrown out. So whether there's 97% or not, first of all, let me point out I just had to talk to journalists. There was a conference of 2,000 people, I think it was, who thought the earth was flat, most of them PhDs. Okay. So the
Oh my
fact that those
word.
PhDs think the earth is flat, all it means to get a PhD is you got a PhD. It doesn't mean a damn thing, right? So therefore, taking percentages of people and saying, look, there's some PhD scientists that think the earth is flat. Therefore, maybe there's a possibility it's flat. Well, it's not flat. You want to know? Go around it. I've done it. Okay. And I don't care whether there's 1% or a half a percent. It doesn't matter. They're wrong, because the great thing about science is one side is just wrong usually. Okay.
Yeah.
And there are things that are controversial, and we learn, and that's okay. But so what they're saying is that with 97%, that it's not controversial among climate scientists. But the major thing is that the predictions, as I said to you, you can use the theory. The theory predicts, and you see what the theory predicts, and on the whole, it's right. Okay. Now there are some people there are skeptics and there are deniers, and I think there's a difference between the two, and you should really be careful about using that term for
Mm,
everyone. There are those who say, look, it's not happening. It doesn't matter. It's not happening. So the same kind of people who say the Earth is 6,000 years old. I don't care what you say. It's not happening.
mm.
Or the Earth is flat. I don't care what you say. It's not happening. There are skeptics, however. That's quite a different thing to say, well, first let's look at the weak points of these arguments. And some of those people, for example, the impact of clouds or precipitation, and so they would point out, hey, the models don't necessarily address clouds very well. And so that's a true point initially. But what's happened is the models have gotten better and have addressed clouds, and
Yeah.
and the results still remain the same. And the basic underlying physics is independent in some sense of how effectively clouds do things, because we're talking about energy in and energy out. The details of of temperature change here or there, ice melting here or there, depend on complex models. Okay. And so that those are details are subject to sometimes more uncertainty, because more variables need to take into account. But the net effects, the global effects, which are the things I really want to concentrate on. It's what I even do in my physics study. Looking at the whole scale of the universe is
Yeah.
sometimes easier than understanding what's happening on Earth. But anyway, so some of those people who don't agree might say, I don't accept the predictions of those models as much as other people. Okay. And then sometimes, the problem is with scientists, it's like looking at children, who are always beautiful to their parents.
Yeah.
And and so people who spend their life working on, say, a cloud model, and their model, they're often less willing to to
Yeah,
accept other
yeah.
people's models, and that, so there's a lot of that in science, especially at the edge of it. And so you expect some people to say, well, I just don't trust it. I know I debated one client scientist once who was a skeptic slash denier, and a good friend of mine who was also there and is a client scientist was pointing out
Hmm.
that basically, and I'm not going to name the name, but basically he felt he was smarter, and he was very smart. Okay. He's at a major institution, that he was smarter than the people doing the models. He hadn't done them. He hadn't followed them, but
Mm,
he basically said, if I'm not doing them, they can't be very good.
mm.
And there's
Not a great
that.
argument.
So it's a human kind of thing too. And my friend Freeman Dyson, who was was an amazingly smart scientist. Well, he was naive, and he was saying, well, and he didn't doubt, by the way, the existence of global warming. What he said was maybe it'll be good for the Earth, but his arguments, he didn't follow the models in detail either. And he was smarter than most of the others, but if he didn't do the work, and so his claims were, I would say, in that sense, irresponsible. I've had many conversations with him before he died about it.
Lawrence, let's get back to your book. Actually,
3% doesn't mean much. It just, you're going to have.
I appreciate that answer. Yeah, absolutely.
I mean, as I say, there are probably some percentage of scientists who think gravity makes you fall up. I don't know them, but I wouldn't be surprised they're somewhere. Anyway.